All right, welcome back, everybody. We are going to now deal with congruence and similarity, which means we're getting into geometry now. Okay, so a little step back from algebraic stuff, for the most part, at least. So let's see, what is it talking about? Congruence and similarity. So just some quick vocab. Congruence means they are exactly the same. So they're equal. You do a little squiggly line. That means they are congruent, exactly the same. Whereas similar, it's just the squiggly line. I mean, I should know what it is, right? But I don't. I'm just gonna call it the squiggly line, right? The N sign. Those of you who understand that, right on top of the N, for like piñata. You know what I mean? Anyways, that's the difference, right? So what's the key difference? Is the similarity. There's no equal sign. That just means they look the same ish. Okay. So we're talking about shapes basically. Okay. And if I'm looking at it, there's some graphs. All right, it looks like we're going to match some sides there. There's a triangle that we're dealing with, the rectangles, more graphs, more things about reflection, rotation. So we're doing transformations here. Then we got this thing, parallel lines with the transversal line. If you're a little lost, this is your transversal, and I assume those are parallel. All right, so let's see. That's another triangle, more graphs. Oh my God, more graphs. So it looks a lot complicated, but I'm noticing they're literally the same-ish questions, right? So it looks like I just got to match the sides here. What's the length? I see transformations, another matching sides. So they're very similar questions. They take up a lot of space, right? So they look scarier than they are. Okay, so let's go ahead and tackle this. All right, and see what we got to do. So you have a rectangle on a coordinate plane. Your teacher tells you to complete the following transformations. So a translation of 2 units down and 4 up, dilation of scale factor of 5, rotation 90 degrees clockwise, I don't know about where, mirror across x equals 4. Your friend claims that this new shape is congruent. So what does he mean? That it is exactly the same. Which transformation proves that your friend is wrong? So think about it, and I'm going to just, for the rest of the whole thing here, when you're talking about transformations, we have rigid versus non-rigid. Rigid means you rotate, you reflect, and you translate. The only other option, can you see there, because they're right here, right? Translation, rotation, and mirrors reflection. The only one that screws it up is dilation. So here's what I want you to think about dilation. Dilation is when I have something like that, and then we're going to be like, you know what? I'm going to go ahead and make this bigger or smaller. Do you see how it's the same-ish? But now it's a bigger shape. Bigger, or smaller. So does it look exactly the same? No. Now compare that to rotations. Well, rotation, if I have that shape, isn't it exactly the same shape? Right? I just moved it around, right? Reflected, I don't think you can do a reflection here, is if I just flip it. So if I go from here and I flip it to the other side, okay, which I don't have the technology apparently for this one on this app, or translation, which is up or down, left or right. These are exactly the same. So which one screws it up? It has to be dilation. Okay. So that is our answer for this one. All right. So this right here is going to be important for the rest of the thing. Okay. All right. Triangle ABC is reflected across the line y equals -2, followed by another reflection across it. Select true or false. So if I have triangle ABC, there's ABC. So what happens is BC longer than BC prime. So again, when it has that, that's the new shape. So did it get bigger or smaller? No, because all you did was reflect and reflect. So it is not longer. They are exactly the same. So that's false. Triangle ABC and triangle A prime, B prime, C prime are not congruent. No, they are congruent. So that is also false. Okay, they are congruent. Triangle ABC are similar and congruent. That is true. So when you're going to find out, you're like, wait, why? They love this question. Similar and congruent. Similar means they are same age. Similar also is dilate. Okay. So essentially, it's your multiplier, like your scale factor. Okay. So if your scale factor is 3, you tripled it. If it's 1/2, you cut it in half, right? You made it smaller. But my scale factor also tend to be 1. So that's where it's like similar, right? We make it congruent. All right. The quadrilateral Aaron is transformed by being mirrored across the x-axis. So I'm talking, so this one is this one right here. Okay, all right. So it got mirrored across the x-axis. So it went this way because this is my x-axis. And then it got translated 11 units to the right and then 10 units up. Okay, I can see where it ended up there. The new quadrilateral will have UXIE, UXIE for the new side. So check the box which side lengths are equal. So you just got to match the corresponding vocab right here, sides. So this one's just like, okay, which one goes with what? So NA goes with which one? And honestly, I'm going to start with the easier one. The easiest one for me to identify is actually going to be the flat one. So OR goes with this one. Okay. And because it's the exact same shape, I just have to go in any direction. So if I go to this direction, now I'm going to this small one. So am I going to go to the right or am I going to go to the left for the new one? Well, in this case, I'm going to go to the left, which means that I goes with NO, which means that NA goes with X, and that means that AR goes with U. Okay. A little hint, this one's easier to tell, but one of the ways you can figure it out is just doing triangles. So what I mean by that is you're like, well, how do I know that AR and O aren't the same ones because they look the same? Well, technically speaking, right, if I do AR, I go like this, and AR gives me 1, 2, 3, 4, 5, 1, 2, 3, 4. If I do this one, this is a 4 and a 5. So to see how they match, okay? If you look at the green one, it's a 2 by 3. Can you see it if you start counting triangles, right? You're like, oh, there's the 3 by 2. There's my 3 by 2. So that's just another way to kind of look at this, right? Like to give you options here. So now the color coding is awesome because I just got to match it now, right? It's pretty simple. Just got to mark it down. So AR is my purple, and purple with purple is U. RO is my blue, so my blue was my E. ON is my red was my I. And NA was the green, so that's my X. So notice it wasn't that bad, right? So that we have a few questions basically just like this one. All right, did I have to go crazy with those translations and reflections and whatever? No, right? I just had to match them up. I just knew that they were the same. Okay, they were congruent. All right, moving on. Rectangle 8 went through a single transformation to create rectangle B. Okay, that's nice. Kendra says the single transformation must have been a reflection across the y-axis. So here's the y-axis. So essentially, Kendra said it flipped. Okay, so it flipped on the y-axis, which, yeah, it looks like it. Because if it's a mirror, it looks like it's 1, 2 away, 1, 2 away. All right, yeah, I can see that. Choose a different transformation that could prove Kendra wrong. Okay, so a rotation of 90 degrees clockwise. So if my rectangle is here, if I rotate it clockwise, that means it should end up there. So that is wrong. If I rotate it clockwise about the point -2, -2, it'll still end up somewhere over there, over here. I don't know. But it's not going to be in the last one because it's only 90 degrees, so that's wrong. Translate 7 units to the right. That means if I move it to the right, will that work? Ooh, it might. Okay. And then my last option was to reflect across the X. So if this is my X, if I reflect it, it should end up over there. So it can't be that one. So my only option is the translation. And will that work? Well, let's check. This is right here, which goes with that one. So that's 1, 2, 3, 4, 5, 6, 7. So yes, it was 7 to the right. All right, triangle TND is rotated 180 degrees clockwise about the origin. Will form triangle TND prime. Choose all the transformations that will also create TND prime. Okay, so I don't know where it is, so I'm just going to pretend like I do. So I'm going to say my triangle is right there. If I rotate it 180 degrees, it's going to go 90 and 90. So now it's going to look like that. Okay. So if you don't believe me, here it is. So there's 90. There's 180, right? So notice, there it is right there. Okay, awesome. Okay. So if I rotate it counterclockwise, will that also work? Yes, that one will work. If I do a scale factor, no, you just made it bigger or smaller. And this one you made it bigger, so that doesn't work. If you reflect it across the Y, so there's your Y. So if I reflect it that way, now it looks like this. And you reflect it across the X, so now I go that way and I flip it over. Yeah, that works too. And then if I translate it 10 units down and 10 to the left, so if I go down and to the left, no. And even if I go to the right, the original is pointing up and the new one's pointing down, so that won't work. So those two are my options. Okay, and I don't want to put an X because some of you guys are like, that's wrong. No, it's correct. Okay. All right, here's the next one. Look at the figure below. Okay, so I got mu and mu prime. Read the statements of each row and determine whether it's true or false. Triangle mu is reflected across the y-axis. So where's triangle mu? Mu is right there. Okay. So if I reflected, that means now it looks like this. So that's false. Okay, it can't get reflected. What's my other option? It is rotated 270 degrees counterclockwise about the origin. So 270 degrees counterclockwise, that means it's going to the left. So there's 90. And it went over there. There's 90 on this side. And there's 90 on that side. So does that work? No, that does not work. Mu is rotated 180 degrees about the origin, then translated up. So let's see. So there's 90. There's another 90. And now we're going to do what with it? We're going to go 10 units up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one is correct. And notice, if you haven't figured it out, when you rotate it at the origin, this is negative 2, 2. So this will be negative 2, 2. This will be negative 2, 2. You see that? And this will be 2, 2. Right? If you had kept rotating it. So that's why the first one didn't work, right? The 270 did not work because I didn't have that point right there, right? So that's the way it worked. Okay, so let's see, determine. So there, we talked about that earlier. Parallel lines got it with a transversal. So what this means is, and I'll just give you a quick rundown on this whole chapter because that's how long it takes, like in high school. There's only two angles, okay? They either say angle plus angle equals 180 degrees, or both angles are the same. That's it. And there's only two numbers, okay? So what do I mean by that? Well, can you see that this angle is obtuse? Now, if you look at it, can you tell that that's also this angle right here? Can you also tell if I rotate it 180 degrees, it's that one and that one? So can you see, essentially, that one, wrong color, sorry. This one, this one, this one, and this ones are all obtuse. They're all the same number. And that means that this one, this one, this one, and this ones are all the same. Okay? So that's what I'm saying. If one of them is 100, the other one has to be 80, for example. Because 100 plus 80 equals 180, which gives you a straight line. Okay? So anyways, just a little hint, okay? Excuse me. So let's see. Determine whether each angle given is the same as number 1. So number 1. So number 3, are they the same color? No. So they're not the same? Are they supplementary? Yes, because if I showed you, right, if I told you that this was 100 and this one's 80, well, if the 2 is 80, then this one's 80, and that one's 80, and that one's 80, which means that this is 100, that's 100, and that's 100 degrees, for example, okay? So if I do 1 and 3, 100 plus 80 is supplementary. And this is where I told you there's only 2 options, okay? So neither should not work here, okay? It's either one or the other. So that's like a trick question, right? Because I'm like, why would they put that there? Because usually they're pretty good about you have to select at least 1 per row or 1 per column. But this is one of the few questions I've seen out there on the state exams where they're trying to mess with you, okay? All right. So angle 1 and 5. So 1 and 5, they're the same color. So they're the same. 7, so 1 and 7, one's orange, one's green, so they are different, so that means they add up to 180. And 1 and 2, they are different, so they add up to 180. Okay. Number 8, triangle lux is similar but not congruent to triangle ray. Choose all sets of transformations that could have occurred to make this possible. So again, similar, that means it dilates. Okay, it got bigger or smaller. So in other words, there's lux. Okay. And now there's ray. So it could have gotten bigger. I just made it smaller. Okay. So that means they are not exactly the same. So one's bigger, one's smaller. So reflecting and dilation. Yes. Okay, it got bigger. Whatever. Dilation again. So yes. Reflection and dilation. So if it's 3/4, it got smaller. Yes. Translation and translation. Nope. That does not work. Okay. So in this one, it needed to get bigger or smaller, which means, again, you needed to dilate. Okay. If you didn't dilate, it remained exactly the same. All right. So here's again, we're matching. So that's what I was saying earlier. How do I know which one's which? Okay. And then they're almost the same. Okay. So the one that stands out to me is this one. Use my markers here. If I look at it, you're like, well, which one is it? Well, in this case, if I do my little triangle like this, right? This is a 1 by 1, 2, 3, 4, 5, 6. So if I do it here, it's a 1 by 6, right? So there's my purple one. So the question is, what direction do I go? So the problem I'm seeing is they look the same to me. So how do I find this green one? Well, this green one was 1, 2, 3, 4. 1, 2, 3. Versus the blue one right here. That was 1, 2. And 1, 2, 3, 4. So now if I look at my other triangle. So my green one's a 3 by 4. So this one looks like I'm going to have 3 by 4. So yep, there's my green, which means that my blue one is a 2 by 4. Can you see it? There's my 2 by 4. All right. So there I matched it up. Okay, that's the one I showed you, new strategy, right? For some of you guys, it would have been easy. For some of us, it's like too complicated. So hopefully this makes it a lot easier to match them up, okay? So now let's match them that they're color-coded, because now my life is way easier. All right, so AR is purple. Purple with purple means you got E, okay? RC was green, so that's S. And CA was blue, and the blue one up there is U. There we go. All right, triangle HPE with points blah, 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 blah is translated to units down, followed by a rotation around the point, blah, blah, blah. Enter the length in units between H and P. And now if you're like, wait a minute, but how do we get the new triangle? Why is this being annoying? But remember, because it got translated and it got rotated, it is exactly the same. So the distance from the original H to P, so from here to here, is the same from H to P prime. So all we got to do is do the graph. So can we do that up there, right? So where's H? 2, 1. So there's 2, 1. Okay, there's H. And where's P? 6, 4. Excuse me. So there's 6 and 4. So there's P. So the question is, how far is that? And you're like, wait, what the heck? That's not a straight line. Like, I don't know how to find that. But in 8th grade, and again, this is going to be one of those, you'll see it in a different test. Okay, here's a little taste of it. You should have learned a little secret, right? Well, just like I've been showing you in this exact problem, if you can see them, we can make a triangle out of any straight line. And when we make a triangle out of it, we can make a right triangle. Anybody see where I'm going with this? And anytime I have a right triangle, I can use a squared plus b squared equals c squared. So I can use that as my method to solve. So there it is, a squared plus b squared equals c squared, where my a was 1, 2, 3, 4, and b was 1, 2, 3. So that gives me 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. 25 equals c squared. And how do I get rid of a square? I take a square root. So that does not cancel. It gives me a power of 1. Okay. So before, if I had 3x equals 12, I would say divided by 3, and this gives me 1. Right? They slash, they cancel. No, they don't cancel. It gives you 1x. Well, now I have a c, but because I am canceling, I'm not canceling, I am simplifying the exponent. Now it's c to the power of 1. Okay? So what does that give me? Well, let's use our calculator. I like to have them both. There we go. Okay, so if I take the square to one side, I take the square to the other. So the square root of 25 equals 5. So c equals 5. That is the length. Okay. Now this one we didn't get lucky, right? It was diagonal. But maybe if you did get lucky, they'll be like, oh, it's from here to here. Then you just count 1, 2, 3. Or they could have said from like here to here. Well, it's flat. 1, 2, 3, 4, 5. All right. So notice, I think I was just being mean to you guys on this one. Hopefully the other ones are easier. But those are your only 3 options, right? It's either a vertical line, horizontal line, or a diagonal. So if you get a diagonal, you got to use a squared plus b squared equals c squared. All right. Blah, blah, blah. 2 more. All right. And these are the same questions. Same thing. All right. So triangle ZEC is transformed by reflecting, okay, then rotating. The new triangle ROM. So let's match them up. Okay, no problem. This one's kind of easy compared to the last one at least. So this one is my flat one, which means it should be that one. Now if I look at it, this one is going to be a 3x3. So if I do this one, that is a 4x3. So it can't be that one. So it has to be the other one. Right? And you can see it, a 3x3 right there. Which means that my last one is this one right here. So now let's go ahead and match them up. Now that I color coded everything nicely. So ZE. ZE is my green. So that's my M. CE is my yellow. Is that yellow, orange? Yellow, orange? Whatever. Is my R. And then ZC, damn, that's hard, is my purple, which goes with O. Okay, so hopefully you see this is the third one. Not that crazy, right? Okay, and the last one, OPE, shown below, is dilated. Okay, so it got bigger or smaller by a scale factor of 4. So you need to multiply by 4. Okay, it got bigger. What's the side length in units of EO prime? So here it is. There's my EO. 1, 2, 3, 4. So if my EO was 4, how did you get to E prime O prime? Well, I multiplied by 4, right? I dilated. So if I do this to the 4, that means that this one has to be 16. There, not that hard. Okay, not that bad. And if they give you a fraction, you can always use a calculator, and they would be like, oh, 4 times whatever fraction they gave you. All right. And if they do, I'm hoping they're nice, and it was like it gives you the whole number. Okay, like 4 times a half, for example, or 4 times a fourth. Anyways, that was it for this one. So I am done. Okay, until next time.